So, we were doing some numerical problem started and we calculated up to this in the previous. This was the circuit, we calculate the equivalent impedance just like resistance rule and calculated, first calculate all the currents I 1, I 2, I 3. Then we calculated finally what was the total power or complex power supplied by the source. I am talking about the power balance in AC circuit, how to do it. So, these results I got. Now, what I will do is this, I will calculate, I will better copy this thing, this circuit at least. So, this was the problem we are trying to solve. Okay. So, this is the thing, and we have got, oh my God, and we have got this thing, power, complex term I am not, total power, whatever it is, total power we have calculated up to this, total power, total means complex power supplied by source. Let me rewrite, these results we already got, supplied by the source is equal to this number, copy this. This is what we have got. So much what? So much volt ampere. Now, I will calculate what is the complex power. See, this is one load, one impedance Z 1. So, I will write total power or complex power absorbed by the element Z 1 bar. This is Z 1 bar. So, these are its two terminals. And you see current is entering through I 1 through A, and so if you calculate V bar A B into I 1 star, then in language I will tell this is the power absorbed by the source, because through the plus terminal of this voltage, plus minus if you write, it means I am talking about VAB, I told you many a times. So, I am writing nonetheless very specifically V bar AB into I 1 bar. Now, the question is what is V bar AB, then I have to calculate. V bar AB can be easily calculated, because I know I 1 bar. So, in an impedance like this, if this is Z bar, this is the current, then potential of this point with respect to this will be I bar into Z. So, I will calculate. So, now V bar AB will be equal to I 1, do not take I 1 star here that will be totally wrong, I 1 into Z 1, this will be the thing, and I 1 already I have calculated in the previous page, which was 21.07 and angle is minus 16.69 degree, and Z 1, value of Z 1 is 3 plus J 4, 3 plus J 4. So much volts. So, V bar A B will be eventually coming as 135 in rectangular form. I have calculated, it can be minus j 62.5, so much of volts. This will be V bar A B. Then this calculation I carry on. Complex power absorbed by the load is S 1 bar. I will say it is this voltage this voltage is this 135.14 minus j 62.5, this is the voltage into I 1 star into I current absorbed. So, I 1 star and I 1 was already known to be, let me write down, I 1 bar was equal to, we got it 21.07 into angle of minus 16.69. Let me write down all the currents we have already solved. I 2 bar, I got it 14.89 and angle 28.31 degree, and I 3 we got it to be also 14.89, but angle is minus 61.65. This is what we got last time. So, here is I 1 star. So, it should be 21.07 and angle is 16.69 degree. And if you calculate it, the complex power absorbed by S 1 will be 1331, it will have a real and imaginary part 0.83 plus j 177.5.64. This will be the thing S 1 bar. Hopefully, it is correct. Similarly, I will calculate the power absorbed by Z 2. I am stressing upon this point, I am calculating power absorbed by S 2. So, S 2 once again this voltage should be known. So, let me write in longhand, power absorbed by S 2 by Z 2 I am calculating, which will be equal to say S 2. Let us use a different color for S 2. S 2, it will be equal to V bar B C, this voltage, V bar B C potential of B with respect to C, and then I 2 star. This is what I have to do. Now, the question is what is V bar B C? V bar B C will be, if you calculate, so you calculate it here somewhere, V bar B C will be nothing but this current, that is 6 minus J 8 into I 2 bar. I 2 bar is 14.89 angle 28.31 degree. and if you calculate it, it comes out to be 135.14 minus J 62.5 volts. This will be this thing V bar B C. So, V bar B C is this. So, I put that number 135.14 minus J of 62.5 into I 2 star. I 2 is this. So, I 2 star will be 14.89 into 28.31 degree, but I 2 is this. So, angle must be negative minus 20 t, and if you calculate it, it will be equal to. So, this will be 84, please correct that. This real part calculation is it coming? You tell me, I will write 84.8 plus or minus plus J 62.6 volts. So, this will be V bar A B, it looks like. Okay. Therefore, this I have to then correct it, V bar A B. So, one has to do peacefully to calculate this one. 84.8 plus J 62.6 into this. So, this will come then somewhat different. This, how much it comes? So, I star into V 1332 plus J 17. This will be the thing I have told, there was some calculation mistake. Similarly, power absorbed by Z 2 will be V bar B C into this one. And this calculation, if you calculate as per my calculation, it is becoming 133.0.21 minus J 1773.60. This will be the power absorbed by S 2. Anyway, we will confirm this calculation. Similarly, power absorbed by Z 3 will be V bar B C, same voltage V bar B C into I 3 star. Now, V bar B C is already known, that is 135, same voltage 135.14 minus J 62.5 into I 3 star. I 3 is 14.89 and angle will be plus now 61.65 degree. So, this one will become 1774.53 plus J 1328.98. So, we have calculated the power supplied by the source. I am now putting some circle to them. Power absorbed by Z 1, this one, and power absorbed by S2 is this one, and power absorbed by Z3 is this one. Therefore, I will write total power absorbed by all the loads, total powers absorbed by all the loads, that is by Z1, Z2 and Z3 and Z3 will be sum of this plus this, these three you add up. Is not three numbers. How much it comes? Real part? No, let me write whatever you are getting. 4438 reactive part, it is 01328. No, this will cancel out, na? Almost. So, how much? Minus 1777 plus J1332. This is the total power. So, real power, it is coming close, but there may be some little mistake I have made. So, you see this sum, this number should be same as this number, that is what I am telling. Total real power supplied by the source is 4393, it is slightly higher. Can you just check once again that calculation, that will confirm. Reactive power, okay, it is matching. So, calculate this V bar A B once again. So, you see what we have done, we have calculated the total power supplied by the source, both real and reactive, in one stroke, voltage into a current star. Similarly, the same steps I have repeated to calculate the power absorbed by Z1, Z2, Z3. And what I am telling is power supplied by the source must match the power delivered to the source or absorbed by the source, and it will come same identical, but anyway there is a slight mistake or whatever it is, maybe 4.4 kilowatt, 4.3 kilowatt, in terms of that we are getting, but you just check once again your calculations. It is close by, but then maybe some because of truncation I have made some error. But the point is clear, in a circuit analysis, if it is AC circuit, then supply voltage, if you know all the impedances, solve the circuit, get the currents, then calculate individually, if it is load, how much power it is absorbing, that you calculate, and if it is source, how much power it is delivering. P plus jq, the sum of all these things on the load side and the source side must match. Therefore, in AC circuit, source must be able to provide the reactive power. If you find the important point I want to make, for example, in this case, previous simple problem, that RL circuit problem, we have calculated power supplied by the source was 2400 plus J3200 P plus JQ. So, active power supplied by the source was 2400 and reactive power supplied by the source was 3200. Similarly, reactive power absorbed by the source has to be this one. Now, what I am telling is the sign of the reactive power for lagging power factor load or inductive circuit, it is coming positive. If suppose the it was a capacitive circuit, suppose minus J8 ohm, then you will see the reactive power. Are you getting me? So, what I am telling in this note, note it down. If your circuit is reactive only, but 6 minus J8, sorry, capacitance, minus J8 ohm, and if your supply voltage is same 200 degree, this much volt, then everything will remain same. Only thing, the currents will be now leading, it will be this current will be leading 20 angle 53 degree, is not? Current will be leading the supply voltage is 200 degree. Now, if you calculate the power absorbed by the source, absorbed by source by load, it will be voltage 0 degree into current star 20 minus 53 degree. If you calculate this, it will be real power will remain same, that is 4000 real part, but this sin theta minus sin theta. So, minus J 3200, this is so much var it will be, and this will be so much kilowatt. That means, the reactive power for capacitive load absorbed by the load is minus 3200. Had it been inductive, we would have said it is absorbing. So, it is absorbing minus 3200 watt, means it is delivering 3200 var to the system. So, inductive reactive power, we just interpret it, it is absorbing reactive power, but they are same nature power, nothing doing like that, but we make a distinction from this sign whatever it is. If I say a circuit is absorbing 10 minus J 50 watt and var power, I will come to know, oh, this is a capacitive circuit. See, if I say it is a real part will be always positive. Therefore, a capacitor source can be considered to be generating reactive power. We could other way also say inductive power generates, it does not matter, but we come from this sign, we will be able to come to know whether the circuit is capacitive or inductive, just looking at the sign of the reactive power. Got the point? Therefore, it is very easy to calculate the power balance of AC circuit also. I will give you several problems, but kindly once again redo yourself this problem, and if possible you correct the numbers here, so that it is closely coming, but it should come equal if you do not truncate anything this that. So, that you can mail me and correct it. But the essential point is, I have told you that in AC circuit we can calculate, we can do also the power balance as we did in DC circuits, but here real and reactive power, and reactive power does not it is the oscillating power, and if a circuit is inductive, its reactive power will be positive, that means absorbing power. So, this volt ampere curve that I have, a triangle I have drawn, it can be drawn like this. For inductive circuit, this is P, this is Q, JQ, and this is S. Both real and inductive power will be positive, load absorbs so much. For capacitive circuit, it will be like this P, and its reactive component will be minus JQ, that is what I wanted to tell, S, and this is the power factor angle of the load. You just solve several problems and you will be able to get the idea. You by this time you know all these things, but calculations of the steps will be then. B is known, get I using the relation supply voltage by Z bar, etc. Then get power supplied by the source and power means total power absorbed by the load. This is what we did in this calculation. Once again, you know the power is real power, so far real power is concerned. It is like V I cos theta, I told you. Now, V is equal to I Z, I told you, magnitude of Z, and this is I cos theta. So, this is equal to I square into Z cos theta, but Z cos theta is R. So, real part of the power absorbed by the load also can be calculated if you know a circuit is RL, but you know the current through it, then you can be rest assured real power is I square into R, RMS current square magnitude into the value of the resistance. Got the point? So, in case of AC circuit analysis, we calculated current. For simple circuits, series, parallel circuits, you apply the same rules to calculate the currents. Once you know the currents, you can calculate the voltage across any of the impedances I into Z and so on. Therefore, I will be now able to solve a rather complicated AC circuit once again by applying the nodal analysis as well as the mesh analysis. For example, you have a circuit like this, nodal, I will just indicate this, nodal and mesh analysis can be adopted to solve network problems in the same way as in DC circuit. Now, let me just give you one example. Suppose you have a circuit like this. Now, you convert the impedances in terms of complex numbers. There may be multiple sources present, I do not care. Suppose here is a voltage source whose phasor notation is V1, here is another supply whose phasor notation is V2. Polarities must be indicated, and this is suppose Z1 bar, this is Z2 bar, this is Z3 bar. I want to get the currents. So, what I will do? I will now assume the current phasors as I1 bar and I2 bar. Why this can be done? Because V equal to IR in DC circuit, here similar thing in AC circuit is V bar equal to I bar Z. So, no point in repeating to prove that it can be done, because V and Z follows this relationship. So, I will write by inspection the KVL equations in loop 1 and loop 2. What it will be? KVL in mesh 1 and 2 will be like this. Coefficient of I1 will be simply Z1 plus Z2 into I1. Coefficient of I2 will be this one, and this should be equal to V1 bar, the sources. Polarity of plus is such I1, same rule. Similarly, the second equation will be coefficient of I2 will be Z2 plus Z3 into I2, and coefficient of I1 will be minus Z2 into I1, and this is plus, and this should be equal to the source voltage, but here it should be minus V2. Then you have got two equations to solve it. Only thing complexity arises because these numbers you have to handle in complex number. Then apply Cramer's rule, this, that, whatever it is convenient to you, get solve for I1, I2. Acha, in this example, tell me there are each elements are there. What is the voltage drop here? I1, Z1. What is the voltage drop here? If you write this is plus, this is minus, then you should write I1 minus I2 phasors into Z2. For this simple, I2 into Z3, and polarity of the voltage I2 is known. Now, here let us see what should I write. Power, knowing the direction of the currents and polarity of the voltage, I say that power delivered by the sources This one really delivers, okay, V1 I1 star, is not, this is what I will write. Now, look at this source. It is V 2 I 2 star, but current is entering through plus. So, I should write power absorbed by the source is V 2 I 2. But anyway, I will then minus I 2 is going away from plus for this source. So, I can write it like this, which will take care of this thing. Got the point? Similarly, I will, so net power delivered by the source will be V 1 I 1 star and minus it will be minus star is 180 only. So, it will remain I 2, this is fine, this fellow delivers and this fellow absorbs. So, minus. Similarly, power absorbed by the source, all the loads power absorbed. This language you decide what you will write, absorbed by the loads will be Z 1 will be voltage across Z 1, this voltage V Z 1, and I will say I 1 star. For Z 1, Z 2, what is the, suppose and I am adding them now, V voltage across Z 2 with this plus this minus. This one I am writing power absorbed. So, I will say it is I 1 minus I 2 conjugate of this, and power absorbed by Z 3 is V Z 3 voltage across Z 3 with this plus this minus into I 2 star. And what I am telling is this must be equal to this V 1 I 1 star minus V 2 I 2 star. With numbers it will be much more easier to write, you can easily write this. So, total power delivered to the system or the circuit is this one, and they are being absorbed by different loads. Now, whether actually a load is absorbing or delivering power, that depends upon the sign. Reactive power, real power sign will be always plus resistance, but reactive power, okay, inductive. If it absorbs power, it means it is there is some inductance present. If it is delivering power, a load, reactive power, which will become minus, because the way I have calculated absorbed. So, if it becomes minus means it is pumping reactive power to the system. Anyway, we will continue with this in the next class with nodal analysis I will point out. Thank you.